So in conclusion, Vietnamese people do need oxygen.
Yes, they do.
Okay, that's recorded.
Yes.
All right. But yeah, so I found out that bigger folks do require more oxygen than littler folks, which became a problem at 7,000 feet when I was the main driver. Only driver. Yeah, because my wife won't drive up in mountains and stuff.
Mm-hmm.
So I just took a nap and just let kind of God take the road, take the wheel. All right. So we're rating repeat. How do we decide repeat would work? Is it going to output like a listy thingy?
Yeah.
Let's see. Where's mine? Got a keynote open? Keynote. All right. So repeat is going to take a lambda calculus expression being the so we're repeating something
A certain number of times. The thing you repeat is.
Oh, so this is the first thing, and this is how many times we're doing it. And
Other way.
I'm sorry, this is how many times we're doing it, and this is what we're doing.
Yes.
Okay, and this guy is did I say it only needed to work for like lit and var expressions right now?
Yeah.
Okay, so this is going to be a single lambda calculus expression at this point, not anything crazier. Can it be like an app expression? I assume it could be an app expression.
You just said lit and var, but I mean it'll print anything out multiple times.
Okay, so it'll boil that down to whatever it is that many times. That's what it ultimately does. So if this guy was, I guess what I'm asking is this. Let's say it was a, this second thing here was a app expression that had a lit expression 2 and a lit expression. Actually, we now take lambda expressions, right? Lambda expression x, and this would boil down to, let's just say x, something like that, and we took in a 2. That should work. So this is, we're going to do 7 times. What are we going to do 7 times? We're going to apply this lambda expression to this input.
Okay.
So that should work. So that should give us a 2 7 times. All right. But if I specifically said it only needed to work for lit and var, that's fine. But I actually think it's going to accidentally work for this anyways, because we're calling apply expression, right? Mm-hmm. Okay. Yeah. So let's go ahead and write this.
Apply app expression just holds it that way. We aren't.
Who?
We still call apply program inside of there, wouldn't we?
Who? Yeah, this is still part of our program.
Yeah.
So it's going to be it's going to be apply expression that we're editing here to give us another production of our grammar.
Okay. Yeah.
And just before I forget, I think it actually will go live right after class today at noon. But we have a midterm. It's online, so it's on Blackboard, and the usual stuff. 10 questions. Very similar to my traditional exams. In fact, I'll spin through the slides here real quick just so you kind of know what to focus on. I think I give you 75 minutes to take it. But I say, make sure you have 50 minutes available before you sit down, but it doesn't like shut you out until like 70 some minutes. It has to be in by midnight on Thursday.
Like this Thursday?
This Thursday. That gives you like almost 5 days to work on the thing. So you pick an hour in the next 4 days that you are willing to sit down and spend an hour with Blackboard and take your exam. All right. All right. So, Yeah, I mean, it's going to cover everything up to what we've done at this point. So cars, cooters, variable environments, anything you've had homework assignments over, it's going to be potentially fair game. Certainly lambda expressions, understand grammars and productions, know what a predicate is. Do we sing again?
No.
Yeah.
I mean, this was in class, so it's potentially is on the exam.
Yes.
Uh,
What? Next year, guys.
No, what's the date?
V's birthday.
yeah. So in any case, that's the. There might be some questions on the exam where map would benefit you, but I don't believe I ask you anything specifically about map. But at this point, you should all start to think about map in many of the questions.
Okay.
A lot of times it makes your life easier. I don't know that there's very many, well, in fact, there wouldn't be any question that you would have to use map for because you could always just write your own version of that. But there are plenty of questions where map becomes your friend if you decide to use it for stuff. Okay. And I think it's set for adaptive release. So the exam goes up, I think, at noon today. It unlocks. That way I had this opportunity to tell you about it and you just didn't find out about some announcement. And then all of a sudden I have to deal with 30 questions on Slack about when's it due, what's this? Because you don't want to look at the due date on it and all that stuff.
Just in case it starts right away or something like that. You know.
It releases at noon. It's due by 12:15.
Start.
If you haven't started yet, it's late. Yeah, so sometime between now and midnight on Thursday. Well, I would probably not start it later than like 10:30 p.m. on Thursday because it disappears at midnight, and I don't know what would happen if you started it at 11:50. It might just submit at midnight. I wouldn't risk it, is what I'm saying. But I have to have midterm grades in on Friday, so you'll get they'll all be graded right away, sometime on Friday. Okay. What's who?
I think that's all of the midterm happened this week.
Potentially. Or your grade will just be based on what you've done up to that point, not necessarily including a midterm exam. I mean, a class doesn't have to give a midterm exam. But at this point, your grades would be based on homework, which might be artificially inflated if you always do the homework. Because I tend to grade homework relatively easily, as long as you're putting in the effort and learning from it. But we'll find out, and you'll find out on the exam, whether or not what you're accomplishing in the homework is translating to actual knowledge. I have my same policy, so if you bomb the midterm and you do well in the final, it'll replace your midterm exam grade. So it's not the end of the world. Okay, so we'll insert this guy right here before else. Because we're looking at we need to give constructors and stuff for this guy, right? Or at least might be helpful.
Mm-hmm.
All right, so we'll put it. So we're going to define a repeat expression to be a lambda that takes in a number of times, that's the first parameter, and a LC expression. And actually number of times though is not just is it just a number? Or it can be a lambda calculus expression, right? Because you could have a variable.
Set it with a LC expression.
Okay. Because it could be a var expression or a lit expression, or I guess an app expression if it boils down to a number.
And since all of our app expressions do.
Yep. So taking two, we'll call this guy, let's call this number of times expression. And body expression. Something like that.
I don't know if you want to change the repeat.
Yeah, spelling
or
error.
like one slash instead of.
You don't know if I wanted to change that, or are you suggesting I change it?
No, you should
I don't
change
know
it.
if
It's
you
wrong.
want to change it or do you want
Alright.
to screw it up later on.
Well, I'm probably going to screw it up later on anyways. All right, so we have our lambda here, and what we want to do is we want to build a repeat expression like this, passing it our, what format do we use for our, okay, I see, we used list. So we're going to create a list out of repeat expression, then our number of times expression, and our body expression. All right, so that's that guy. And then we'll go ahead and give ourselves a predicate for this. And this guy is going to just return whether or not the car of our LC, well, actually this guy needs to have a lambda, right? This is a lambda that takes an LC expression as a parameter and returns whether or not the car of LC expression is equal to this dude. That's our predicate for it. Go ahead.
Are we gonna have the constructor spit out all the repeated parts, or just the body ones?
Who?
Right now in the constructor, we're just giving it spitting out the thing that we want repeated once, correct?
Yeah, because that's what, I mean, this just builds for us an expression. It hasn't applied it yet.
Okay.
So what did you, okay, you could have done it two ways, I suppose. You could have had your constructor go ahead and unwrap it. And so did you have your constructor take in a number, and instead of it boiling down to something that has this and this, it boiled down to repeat expression with body expression duplicated this number of times?
Yes.
That's what you had yours do. That's fine. We're going to ultimately do that in our apply expression. What I'm thinking is why that might be a problem. Will it be a problem? I'm just thinking if one of the expressions changes the environment. Probably wouldn't be, since repeat knows exactly the number of things. Yeah, I don't think it'd be a problem. But in sticking with our pattern here, I'm going to leave it as its pieces. That might be helpful to us or something. So I'm going to give myself a couple of getters here. So we're going to do define repeat. How do I say, like for lambdas, do I say get body? Yeah, get body. Get get takes an LC expression, and this guy is going to boil down to the catter of LC expression. So that'll give me the count of that guy as an LC expression. Then we have a define repeat get body. This will be a lambda LC expression. This guy should return the cadder of our LC expression, like that. That'll allow me to extract the body. Okay, so let's, those are our constructors and our getters and our predicate. Anything of a question about that? So I'll go ahead and copy repeat expression there. We'll come down to apply expression. We'll throw our next production on here. So if the type of expression I'm looking at is a repeat expression, then what do I want to do? I need to apply expression some number of times to the body of this guy. Okay, so I'm going to go ahead and we're going to create a, we're going to run this guy internally and output a list. That's what we're ultimately trying to do, right? Okay. So what I want to do is I want to get my pieces of this guy. And so let rec, is all one word like that? Because we've used let and let stars. And we talked about let recs?
Yeah.
Okay. So I think let rec is a good example for this one. Any of you use let rec for it? Use like a helper function? Or did you do Blaine's ultimate constructor? And what, map? Actually, we could just map across. That would have made it friendlier to unpack it up in the constructor and then map across. Did you even at least use map?
No.
Blaine.
I know we're supposed to do this.
You,
Just said build constructors and stuff like that.
are we supposed to do apply expression too?
No,
Really? Are you lying?
you didn't say anything about that.
Really?
Your example is super simple. Just that's why I was just been wondering. What
My example shows.
Repeat expressions and appropriate stuff.
Where's my example?
I mean, that's kind of simple just to write it.
Oh, where's my example? No, no.
I mean,
Hold on.
I guess.
Didn't I have it written somewhere? I had a bunch of 5s. Yeah, here. That's the output.
Yeah.
But you just changed the app thing up there, so
Yeah, so I'll change it back to its simple. Oh my gosh, why? Why? Yeah, so I had this guy as lit expression 5, right?
So I'm gonna print out a whole bunch of 5.
Yeah, that's applying that expression. We're applying this expression this many times. Your output will be a bunch of 5s. That's what apply expression does.
Aren't you using constant? I don't know.
Well, no, okay. We have in our interpreter something called apply expression. We're writing an interpreter that executes a program. Make sense? This is the expression we are executing. We are executing a repeat expression that repeats something this number of times. What does it repeat that number of times? This guy. So what would the output of that expression be? It would be this guy. And the way we get our output is by calling apply expression. That's how we get outputs. How is this different than the previous assignments? Help me understand why it's confusing. Did anybody do it this way? Like call apply expression?
I use this way, but I mean, I use call program or apply program. That's what I did.
Well, yeah, so apply program is the first part, which then calls apply expression,
Right.
right? I'm getting blank stares here. What's
I mean,
like this?
because-
This is super simple.
Yeah, because like the list expression split out 7, and then the other one split out 5, and then you just told us to like repeat the 5.
Yeah, that's what apply expression does. It outputs something some number of times.
So then I just need to write an expression that's like,
Great.
I don't know. I just need to display
Inside
5.
of apply expression.
Okay, I guess. I mean,
That's what we're writing here is an interpreter, right?
I don't know. I said something wrong during the weekend, but I don't know why is it so wrong.
All right, well, let's finish writing it. So we have this guy. I'm going to go ahead here. We're going to leave it as a let at first, and I'll extract my pieces, and then we'll see that we can use a let rec. So I'm going to create a let here, and we're going to have a couple of name value pairs. So I'm going to get my count. So this is like my repeat count, right? So my count is going to be my repeat get count of expr. Like that. So that'll get me a count, but it won't get me the actual count. That guy will get me the lambda calculus expression that relates to my count. How do I get my count? right now, this dude gives me a lambda calculus expression that I presume would either be a var expression or a lit expression. How do I get the actual number out of that?
You have to.
Not Jack, somebody else. Go ahead.
Apply expression on that?
Yeah, you call apply expressions. Apply expression gets this guy down to an actual number. So we'll call apply expression. Is it the full word like that? Passing it my expression and passing it the current environment. And that will give me my count as an actual number. That's the number of times I want to repeat something. Everybody cool with that? All right, next we have our body. Now this is something that we just want to get the lambda calculus expression right now because this is the guy that we're going to do count number of times. All right, so we're going to say body repeat get body from our expression. So that is our body variable. That dude is still in lambda calculus expression costume. All right, he has not been apply expression yet because we potentially might be moving towards something where we want to have each part of the body, each time through the body, might modify our environment potentially. We don't know how to do that yet, but that's something that could happen. If you think about a for loop, we could be changing a variable or adding a variable or something inside of a for loop. And if that happens, the next time through the loop might have a different output because of that modification. Make sense? All right, so I'm just grabbing the body as an expression at this point. So then my output here should be as a list, this guy applied this many times. Correct? All right, so how do I do that? Well, I'm going to need to I'm going to need to have a function that will go through and count, okay? From whatever it currently is all the way down to 0. So if count is 5 and I want to do it 5 times, I'll do it on the 5, the 4, the 3, the 2, the 1, and when we hit 0, we're done, right? So 5, 4, 3, 2, 1, that's our 5 times. So as soon as it gets to 0, we break out. We're probably going to do a bunch of conses because we're constructing a list, right? So I'm going to go ahead and we're going to upgrade this guy to a let rec. So now I'm going to have another variable called call this guy repeatFunc. And repeatFunc is going to be a lambda that's going to take in we'll just call it X for expression. And this guy, what's he going to do? He's going to call apply expression on X, passing it the current environment. Now, what we need to do is we need to add to this a stopping point. Right now, we just say, I'm going to pass this thing one thing, and he's going to apply expression. But I want to call apply expression multiple times. So we're going to say, I want to do this, and we're going to say expression. I think that'll be okay. Well, this will be okay here, but I don't want you to confuse it with this variable up here, so I'm going to call this guy countdown. And I'm going to steal this line right here. All right, so I'm creating a lambda, and I'll actually kick this down here like that. All right, this lambda is going to take in 2 parameters, an X and a countdown, and what's it going to do? It's going to ask the question if equals X 0, then it's just going to boil down to our empty list. Else, it's going to cons apply expression onto RepeatFunc. I'll kick that down a line. Of the same expression, passing it, what does this guy take? Countdown. So minus countdown 1. All right, so that's what repeatfunc does. Repeatfunc is a function that takes in an expression and a countdown, and this guy should be the countdown, not the expression. And it counts down until it's equal to 0. When it's finally 0, it boils down to the empty list. Otherwise, what do? We cons the result of calling apply expression on that expression one time with the current environment onto whatever's returned by repeatfunc, passing it the same expression and the countdown minus 1. That make sense? Now at this point, we've just defined a bunch of variables. I have a count, I have a body, and I have a repeatfunc. I haven't used any of these yet. So now I'm in the body of my letrec. The body of my letrec, I'm going to call repeatfunc, passing it my expression, that's the body, and passing it the starting point for my countdown, which is count. And that's RepeatExpression. So I'm going to get rid of some of those things. And then we'll use our little test guy here. Just repeat the name of my constructor. It's repeat-exp. Let's just make sure that guy looks right. Give me a 7 and a 5. Where's my repeat expression? Just creates a list out of those things. Oh, it's actually calling the constructor on those actual things. So that's fine, but then we actually have hard-coded numbers here, where if I had made this a var expression, for example, yeah, so then those guys aren't going to be it'll work because we're calling our predicates on there. I was just thinking that this is going to be a weird looking output because I was expecting for it to still be in the format of lit expression and lit expression here, not boiled down, but our predicates for those things. Lit expression just checks to see if it's a number. All right, so this guy looks correct. So then what we're going to do is we're going to call, let's just do define test expression to be this dude. And then we'll call apply program, passing it TestExpression. And there's our bunch of 5s. All right, so let's go back up to this guy. Let's make sure we understand what's going on here. Remind me, what does a letrec do? And keep in mind, you didn't have to do this with a letrec. You could have created a helper function or something like that outside of it. You could have done what Blaine did, where he went ahead and in the constructor, he exploded it out and said, hey, here's my repeat. And what does a repeat do? It's going to call all of these expressions. It just happens to be those expressions duplicated out that first number of times, right? That's what you built. And if you had done that, if you had done the upfront work of expanding it out into that, then you could have actually just called map apply expression across that list, across the footer of that list. In this case, so if we wanted to do that version of it, we can say define repeat-exp2, and this guy is a lambda. I'll steal these guys here. So those are the parameters it's going to take, and his goal was to return a list that started with the word repeat and counted down this guy until it finally got to, and then repeated body that number of times. So I'm just going to make a little helper real quick. So define repeat helper. This guy will be a lambda that takes in a countdown and an expression, LC expression. And we'll ask the question if equals countdown 0, then we will just boil down to the empty list. Is this looking familiar?
Yeah.
Does this look similar to your helper? All right, so otherwise, what are we going to do? We're going to cons LC expression onto repeat helper of my countdown is first. So we'll say countdown, we'll say minus 1 like that, and then my LC expression. So that's my repeat helper. So then inside this guy, I will, let's see, repeat helper is going to give me a list. So I will cons repeat onto the result of repeat helper passing it those two parameters. Like that. All right, so now if you do it this way, I mean, keep in mind, what are you looking at right here? You're looking at basically our function that's in our letrec, correct? Mm-hmm. So you can either pre-process it in the constructor and say, hey, here's a list of a bunch of expressions, or you can post-process it and apply expression. Any way you cut it, you're going to have a part of apply expression that's going to change, because this does not execute the code. The output here will be a bunch of 5s just because that second parameter happened to be a lit expression. But if that second parameter was a var expression, nowhere in here would we have actually applied our environment and looked up the value of the variable. If we had a var expression that had an A, we would have just gotten 5 A's, for example, not 5 whatever the value of A was. So we would not have resolved A. Oh, ninja. Oh, so if we're doing it this way and we're using our repeat expression 2,
That's in the environment.
huh?
I feel like if you want to look look up the environment, can you just have the countdown and an else expression and then another environment, and then at the cons, you just put like apply expression with the else exp environment?
Okay, yes, you can do that, but then this is no longer a constructor. That now becomes an interpreter. What do constructors do?
Build things.
Build things. This is constructing our expression in a format that we're going to rely on. That way, if we ever change that, we can change it here and then change our predicate, and then we're making sure we're asking the right questions. What does apply expression do? Constructors build, these guys, constructors build expressions. What does apply expression do?
Breaks them down.
Who?
Breaks them down.
Keep going.
Resolves them.
Resolves them, executes. It executes expressions in an environment. This whole unit's on environment passing interpreters, right? So we are executing expressions in a current environment. So if you start having your constructors take environments and things like that, that's illegal, but now it's not a constructor, it's an interpreter. Does that make sense? So these guys are meant to be simple building blocks that then help us later do some stuff. So what I can do here is just for the sake of, I'm going to call this guy repeat2. And then I'll give myself a define repeat2 exp. And I'll just steal the guy here. And he just returns a repeat2, right? Well, it compares it to a repeat2. So this allows us to now put another production into our interpreter that effectively executes Blaine's constructor version of the constructor. Fair enough. And some of you might have done, how many of you did something very similar to this? Exploded out with your constructor. Okay, but you actually wrote an interpreter. So you executed the whole dang thing.
No, I didn't. I wrote the same thing because like I was thinking if you only pass in the list, then, you know, what is the point of going through all
Okay.
this thing?
Also then,
Because you said that you always assuming that the countdown is a number. So then I'm just kind of confused of why we need to go to extra stuff when it's always a number.
well, because it still was a lambda calculus expression.
Yeah, but it's always a list, so it's always going down to a number.
Correct, but it's still a lambda calculus expression.
I mean,
So you still have to call apply expression on it. Because it could be a var expression that ultimately boils down to a number. Like I could have a var expression A, and A could be equal to 3. So you would need to call apply expression to get the 3 to juice the 3 out of the A. All right, so we're going to test in our environment here, apply expression 2. Or I'm sorry, repeat expression 2. All right, so this is going to be Blaine's version of it. So that's repeat expression 2 expr like this. So with this in mind, we now have a we know that what we're looking at here is, well, we know that the cdr of expr is a list of LC expressions. So with that in mind, what we can do is we can call map lambda x apply expression x e and v. We can map that lambda across the cdr of expr. So that'll be repeat2 expression. So we call this repeat2 expression like that. Is that what I construct? Repeat expression 2. So there's your same output. But notice one's not necessarily, in fact, one's not necessarily easier or harder than the other. I would make the argument that what we've done here is by embedding our helper function, we put one less extraneous function out in our wall of functions in here. Unless we thought that that whole thing about repeating something some number of times was going to be like a valuable helper that we might use in multiple places. If it was, then you can make the argument to make it a global function like we have it. But Blaine's version, so if you just look at this code here quickly, what I have highlighted, notice this guy's a lambda, takes 2 parameters, asks the question, count. Isn't that basically what we're looking at right there? It's the same solution, right? I just used a letrec to embed that function into my interpreter. So I can, and letrec allows me to recursively call functions within a let environment. That's what letrec allows me to accomplish. Okay? So my solution, I took Blaine's helper and brought it into the interpreter. So I didn't have this extra function sitting out here. And then what I did is my constructor here, it's much simpler than his constructor because I didn't apply the logic to it yet. I applied the logic to it inside the interpreter. These guys are both doing the identical thing. Does that make sense? One's not better or worse than the other one. This one just has some of the pieces strewn about, where mine has a little bit more compact but possibly harder to read inside the interpreter. You can make the argument either way. All right, so questions about this one. Plus, this one let you use map, but you didn't use map? Why didn't you use map? You didn't know who? Oh, you didn't even get to this part.
No.
So you did like an awesome constructor, then stopped.
Yeah, basically. I just looked back at the post on Blackboard and say, yeah, I don't know.
Well, so help me understand.
I didn't read that.
Was it confusing, the assignment?
I thought we were just taking literals for a number of times. That's all I did. But
Yeah.
I didn't realize it was.
I mean, it makes sense to
Well, hold on.
keep it.
That right there should indicate that we're not just taking literals, right?
No.
I saw that, but when I saw the example, it
didn't say
made
that.
sense to do it. Like,
This is exactly what that slide said before.
I know, but you didn't say that in class. You said that we're assuming the first parameter is a number. That's what you said.
Just like our app expression last time,
Okay.
where the first thing is a lambda expression.
You didn't say that.
I wrote it. the first element is a lit expression. The second element is the first element is some kind of expression that boils down to a number. So you can assume it's a number, but it's going to be something that boils down to a number, hence the reason it takes a lambda calculus expression. All right, what's the next kind of thing we should write? What we were deciding last time, repeat versus conditionals. We're going to write ifs.
I have no idea.
All right, so for next class, write an if statement. You don't need to, you should support else's. It'll be easier to support else's. So write an if statement that would have, you're going to have to come up with what it means to ask a question in our current environment. So that's going to be kind of an imagination you're going to have to use, because right now we don't have Booleans, and you don't have to build Booleans into the environment. So I might maybe say, you could have it just take in a pound true, pound false, or you can have it operate off of zeros and ones. You could choose either way. Or if it's something boils down to a 1, it's true. Otherwise, if it boils down to a 0, it's false. The way C handles it is 0 is false. Anything not 0 is true. That would be fair as well. But you can use your own imagination for it. All right? But it should call apply expression because we are applying expressions. We are writing functions of an interpreted language. All right, questions, comments, concerns, bribes. All right, I will see everybody on Wednesday. Don't forget about the midterm, due by midnight on Thursday. Don't start it unless you intend to finish it. You only get one pass on it, and once you click begin, it's going to force you to finish. Make sense? I even have it in the instructions. You got 70 minutes or whatever, blah, blah, blah. Go ahead.
Do you have any preferences on how I'm guessing we'll have some programming stuff for with scheme syntax? Do you have any
Yeah,
preferences?
I think it's going to show you the whole exam at once. I'm fine with you writing it on the side, then pasting the stuff in, whatever makes you happy. Just get the answers in there in a way that I can read it. Cool? All right, I'll see everybody on Thursday or Wednesday.